Hello everyone. In the previous class we studied building blocks of the unified modeling language. In the building blocks unified modeling language we learn about the things in the unified modeling language, and next relationships in the unified modeling language, and also the diagrams which are available to establish one particular system, that is the diagrams available in the UML model is also completed. Things, relationships and the diagrams completed. And next we move to the third unit. Already third unit have some idea about classes, relationships, objects and there. So in this third unit we are going to learn the concepts. Here is YV model, conceptual model of the UML, architecture of the UML, classes, relationships, common mechanisms, class diagram, object diagrams. Object diagrams. If we see all about these kind of diagrams in the unified modeling language, we have to know how to draw the class diagram, how to draw the object diagram. At the end of this third unit, we are familiarized with the drawing class diagrams and the object diagrams. See, in this we are having syllabus contain. If time permits, we will see other things. In this, we have to see the why we need a model. What is a model? What is the model? Why we use the model? We have to see. And a conceptual model of the UML. We have already seen conceptual model. Conceptual model of the UML is also nothing but the building blocks. Building blocks of the UML. Conceptual model is also known as building blocks of the UML. Things, relationships, diagrams. That is the conceptual model of the UML. Okay. So now we have to see a YV model and what is the architecture of the model. Let me see about these two things. If time permits, we will move to the classes. What are the classes? What class can have relationships, common mechanisms. So from this class, in this class, you have to know only about the object diagram, class diagram and common mechanisms. Okay, most probably those will see the later sessions, right? So here UML, what is the UML? UML is stands for Unified Modeling Language. Unified Modeling Language. What is a UML? Unified Modeling Language. It is a language of particularly belongs to the design, not for the implementation, design, right? So why do we use unified modeling? Who developed unified modeling language is James Ramba, Grady Booch and also Ivar Jacobson. These three combinedly together have a group. What is that group name? Is Object Management Group. Object Management Group, and they developed this unified modeling language. So, but later, after three persons are developing individually into different notations, and then they formed a group, that is OMG group, Object Management Group. Okay. So, but later agreed to adopt as a standard variation on a notation organization developed by. So, with the help of these three people and David Ambley. David Ambley is developed a common mechanism, that is UML, with the help of those three persons, right? So UML is a accepted by object managed group as a standard for modeling object-oriented programs. Modeling object-oriented programming languages. So UML is a common language for creating models. What is this UML? It is a common language which is used to creating a model of an object-oriented programming language. Especially if you want to create or implement a language, that language belongs to object-oriented analysis and design, object-oriented language. At this particular time, you compulsorily use UML. Okay, so this is about the unified modeling language. So why do we use unified modeling language? Why do we use? So in the firstly, we have to understand what is a successful software. And the primary product of a development team is good software. So what is our final product of development team? So they have to create a good software and also which satisfies the needs of its users and the business. If anybody want to give us a software to prepare or to develop, so at that time what they have to do? They have to do good software. They have to estimate or think good software and also which satisfies the needs of all its users who developed the software or who are using that software. They have to see all this. And also is it working with to the business or effectively working to the business or not, which we have to see. Okay. So next, to develop software, to developing the software rapidly, efficiently and effectively. So and also minimum software rework. Minimum software rework. If any work will be doing again and again, that issues are also very useful in the developing phase. So at that time rework should be minimally create when you developing a software. Minimally do the rework. We need right people. We need right people and also right tools and also right focus on a particular system. Right people, right tools, right focus should also be available to develop a model. Likewise, we are using this model. Modeling is a central part of all the activities that lead to the development of good software. What is a model? If you want to develop a good software, for developing a good software, the UML is a central part. Model is a central part of all the activities that lead to developing a particular good software. Modeling. And also modeling is a proven technique. Model is a proven technique and also well accepted engineering technique also. Modeling, it is a proven technique in the design. Why? Because already some people are developed some designing with the help of these models. It is a proven model and this model is also used in the engineering and technology. Okay. So we build models to specify something. So to communicate the desired structure and behavior of our system, communicating purpose also we are designing these models and to visualize and control the system's architecture, to see what is going on in the system. If you give the input at this particular situation, how the system will acting, what is the next phase while it take the input. So like this many controllability, visualizing of the system and also controllability of the architecture of a particular system which controls. So to better understanding the system, we are building often exposing opportunities for simplification of reusing. To better understanding of the reuse of a system, So we should understand what is going on in a particular system. If you know the what is going on in a particular module or in a particular subsystem, if you know particularly at that time, you have to reuse that particular software in other modules. Okay? So communicate, visualize and control and better understand, and also managing the risk. Managing the risk. With the help of building your models, risk management is also there. Suddenly if any version is changing the computer or the system, that is one type of risk. That kind of risk, more risks are there. Hardware risks is there, software risks are there. So you have to find all those risks and managing the risks are also easy when you use the particular model. You use this particular model. Okay. So we build models to establish, communicate, visualize, control, better understanding and also managing the risk. Okay. And next, importance of the modeling. What is an important? What is a model? Model is nothing but a simplification of reality. Everyone should know about the model. Simplification of the reality. Model is nothing but simplification of reality. Model, it provides the blueprints of the system. What it provides the model? Model will provide the blueprints of the system. Model is going to provide blueprints of the system. Model is a simplification of the reality. That is a model. Okay. So a good model includes, what good model includes? Good model includes the elements which are greater importance. Good model includes whatever the greater elements are there. So those importance will be given. The elements which are having greater importance, those elements should be included, and omits the minor elements. Some minor elements or any elements are there, that elements will be omitted with the modeling. Simply say that which includes important elements and which omits lower important importance to the elements in the design units. Okay. So this is about the importance of the modeling. Importance of the modeling. Next one is the architecture of the modeling. So actually next topic is architecture, and the next topic building blocks of the UML, that is already over, and the next topic, third topic from the third unit is architecture. Architecture. What is an architecture? We have to know about the architecture. Architecture is a combination of, UML architecture is a combination of 5 steps, 5 views. We simply say that 5 views. Vocabulary, that is design view, this is implementation view, design view, implementation view, use case view, process view, and also deployment view. What is the meaning of each and every view? What is the importance of each and every view? Let me have to see. In use case view, what we are observing? In design view, implement view, process view, deployment view, what are there? In use case view, only we have to represent the behavior. In use case view, representing the behavior. And designing view, we have to check the vocabulary and the functionality of a particular module or the system. In implementation view, we have to see system assembling and also configuration management. We have to see system assembling and configuration management. Okay. So in process view, we have to take the performance of the particular system and also scalability of the system and throughput of the system. We have to see in process view how it will work, how it performs. If I give input to the respected software, so how it respective software, how it works, depending upon the process view or the performance, scalability, throughput we observe. Okay, in the deployment view we observe system topology and distribution of the particular operations and delivery, and also installation, how it install works. With including all these kind of views, we have to develop a system, UML system, in a effective way. See, use case view. What use case view will represents? What is the representation of use case view? The use case view of a system includes the use cases. In use case view, what operations is there? Use cases are there. Use cases describe the behavior of the system, as seen by its end users are also there, analysts and testers. With the help of end users, analysts and testers, so the use case view will representing the behavior of a system. Use case view. This view doesn't specify the organization of a software system, this doesn't specify the organization of a software. Rather, it specifies the shape of the system's architecture, use case view. The static aspects of this view is captured use case diagrams, where this use case view will be established in which kind of view? In use case diagrams. Use case diagrams we have to see. And the dynamic aspects of this view are captured in interaction. In this use case view, the dynamics aspects are also there. The dynamics aspects are available to view in interaction diagrams such as state chart diagram and activity diagram. Interaction diagrams, there you see this kind. For every view, you have to represent a static view and also the dynamic view. Use case view having use cases which represents the shape of the system's architecture. That's very important. Okay, and it's which checks behavior of the system. And next one, design view. What is a design view? So design view in an architecture, the design view of a system includes what kind of specifications, which includes only the classes, interfaces and collaborations. We already know about what is the class and how do we design a class, the collaborations, interfaces and also that includes classes. Okay, so not only these, if you want to use these notations, example node symbol or also packages also you can include. Okay, so this view primarily supports functional requirements, which primarily supports functional requirements of the system, meaning the services that the system should provide to its end users. What kind of services which provide? That is compulsorily available in the design view. Okay, so the design view have classes, interfaces, collaborations, and which will primarily support functional requirements, and also which services the system should provide its what kind of services which provide. Those are all available to view in a design view. Okay, so next, static aspects of the design view. For this particular design view, so that represents the class diagram, that represents in class diagram and also object diagram. Static aspects in design view, and also dynamic aspects also used in design view. What are dynamic aspects in design view? Interaction diagrams, state chart diagram, and also activity diagrams. Those diagrams are showing that the behavior of the design view. See here, for every view having some static aspects and also the dynamic aspects. Use case view also having, design view also having, implementation view also having, process view also having. All the views should provide dynamic aspects and also the static aspects. Okay. So and next view, implementation view. Use case view, design view, and the third one is the implementation view. Now we are seeing implementation. Implementation view having system assembly, configuration management, that kind of information is completely having with the help of implementation view. Implementation view of a system includes what kind of components and files are including with the implementation. Components and files. So used to assemble, release the physical system. Why do we use implementation? To release or to construct a particular system, we should have component and files in implementation. So this view primarily addresses what? Configuration management of the system release. What it has, which has the configuration management. What kind of software you use, which configuration is that belongs to. Is it completely working with that particular software or not? That whole information is available with the implementation view. And files that can be assembled in various ways to produce running, is that particular system running or not, you use this particular configuration. And also static aspects of view captured in the component diagram, dynamics aspects is captured in interaction diagrams and other diagrams. Implementation view also having some static aspects, those are available in the component diagram. This will also behave the dynamic aspects. These are available in the in where interaction diagrams, state chart diagrams and activity diagram. All those are available with that. Use case diagram, design view, use case view, design view, implementation view over. Next one, fourth one. Fourth one. What is fourth one? Deployment view. Deployment view. In the deployment view of a system includes the nodes that form the system's hardware topology on which the system executes. On which the deployment view focusing the systems topology, distribution of a particular system, or the delivery of the particular system, or installation of the particular system. That information should be having with the help of deployment view. Okay. So in this deployment view, including nodes that form the hardware, different type of hardware topologies that has. Okay. And also the view primarily addresses the distribution, delivery and installation of the parts that make up the physical system. Distribution and delivery. Deploying in the sense that is the end of the phase, end of the every software. So after readying the software, deployment view will be exists. So this deployment view also having the static aspects and also having the dynamic aspects. Where this deployment view static aspects are only captured in the deployment diagram. The ninth diagram, deployment diagram, which has the dynamic aspects we observed here is interaction diagrams, state machine diagrams are also activity diagram. Okay. So deployment in the sense the end of the project, designing after last phase of the project. Okay. See, in this class we studied UML architecture, and also why do we use what is a model, and we studied model is a simplification of reality and also which produces blueprints of the particular system model. And also we got we have some constructing, implementing, specifying. So for that we see, and this in this class we studied architecture. Architecture of a unified modeling language. Okay. So on the rest of the things we will learn to the next classes. Thank you.